In this lesson, we're going to look at oxyanions and anions with hydrogen. Oxyanions are a group of polyatomic ions with a nonmetal bonded to oxygen. The 5 most important anions, so the root oxyanions that you will become familiar with and use start with nitrate. Okay, you've got nitrogen bonded to oxygen, carbonate, sulfate, and phosphate. In the last column, we have chromate, bromate, and chlorate, bromate, and iodate. And those are just the oxyanions of the halogens. So we write, for example, chlorate is Cl(O3) negative, bromate is Br(O3) negative, and iodate is IO3 negative. And these root oxyanions are given to you in the table of complex ions. These nonmetals can bond with varying numbers of oxygen, which changes the name according to the rules below. Very important to note is that the charge on the ion does not change. So what happens is the oxygens, or the number of oxygens on these root ions right here, these ones, the number of oxygens can go up or down, and then the naming changes. So let's take a look at this instructions here. So the root, right, is one of these, right, like nitrate, carbonate, sulfate, phosphate. And so the example that we're going to use is we're going to use carbonate as the root, right? So we would say carbonate. That's our root oxyanion. Now, if we add 1 oxygen to the root, so we go CO3 negative, and we add an oxygen, right? So now we have CO4 negative right here. Okay, CO4 negative. We've added an oxygen. Note that the charge doesn't change. I now have to add the prefix per. So this name is now going to become not carbonate anymore, but percarbonate. If I take 1 oxygen away from the root, so I start with carbonate and I drop an oxygen, again, the charge doesn't change. I have to change the suffix. So instead of ate, it becomes ite. So 1 less oxygen away from the root, the suffix goes from ate to ite. Okay, so for example, CO2 negative would be called carbon, and then I change it from ate to ite. Note that this is not carbon dioxide because this has a charge of 2 negative. So that makes it a complex ion, and it's called carbonite. If I took 2 oxygens away from the root, then I have to add the prefix hypo and the suffix ite. So this ion would go from being carbonate, now I take 2 oxygens away, and I get carbon, and I have to add the prefix hypo, carbonite. Some oxyanions do not follow these rules. For example, the percarbonate and hyposulfite ions do not exist. However, for the purposes of this course, they will be allowed. So just to practice these rules, we're going to allow these ions to exist. So for the following examples, give either the name or the formula of the following compounds. So let's start with this one, NaNO2. So obviously the root here is the nitrate root, which is NO3-, but as you can see, I have 1 less oxygen than nitrate. So instead of writing nitrate, I have 1 less oxygen. I should write nitrite. So the name of this compound will be sodium nitrite. Next one, CuClO. So ClO, the root for that obviously is the chlorate, which is ClO3 minus. Okay. So I have taken 2 oxygens away from the root. So now this ClO will actually be called hypochlorite, because chlorate was ClO3 and now it's ClO, so there's 2 oxygens away, so we write hypochlorite. This has a charge, the ClO has a charge of -1, so that means my copper had to have a charge of +1, so that we would say then copper 1 hypochlorite, which I have to say because copper is a multivalent metal. Alternatively, I could have said cuprous hypochlorite. The last one, PbNO. So NO comes from nitrate, NO3, but as you can see, there's 2 oxygens that have been taken away. So the formula here, or the name rather, should be hyponitrite. And this had the hyponitrite ion has a charge of -1, and there's 2 of them, so that means lead had to be 2 positive. And note that I have to write lead 2 because lead is a multivalent metal, which means that there are more than 1 possible charge. I didn't have to do that for the sodium because sodium only has 1 possible charge, but I definitely have to do it for the lead 2. So lead 2 hyponitrite, or alternatively you could say plumbus hyponitrite. Okay, next, silver sulfite. Okay, well, sulfite looks like it is just 1 oxygen away from the root, and the root there is SO4 2 negative, so sulfite should be SO3 2 negative. Silver is 1 positive, so that means my formula is Ag2SO3. Aluminum periodate. So iodate, we'll take a look up here. Iodate is IO3 negative. So periodate means that I have added an oxygen to the root. So periodate is not IO3 but IO4 negative. Aluminum is Al3 positive. So then I have Al bracket IO4 3, and that's aluminum periodate. Last one, ammonium phosphite. So phosphite comes from phosphate. Phosphate is PO4 3 negative. If it's phosphite, that means I have taken 1 oxygen away from the root. So instead of PO4, I'll have PO3 3 negative. Ammonium is NH4 positive. So my formula is NH4 bracket 3 PO3. So that covers oxyanions and how we change the name of the oxyanion based on the number of oxygens present. Finally, anions with hydrogen. Positive hydrogen ions can bond with anions with a charge of 2 negative and 3 negative and reduce their charge. So for example, carbonate right here can bond with a hydrogen ion, and we get HCO3 negative, and as you can see, the charge goes down, or rather goes up, because we have a 2 negative and a positive, so that just makes negative. And so we'd write, this is called the hydrogen carbonate ion. And that's given to you in the complex ion table. Or it's also called the bicarbonate ion. For H plus and S2 negative, you can add the H plus to the S2 negative and you get HS negative. And the name of this anion is called hydrogen sulfide. Right? It's sulfide with a hydrogen, so hydrogen sulfide. Alternatively, you can call it bisulfide. Since PO4, 3 negative, has a 3 negative charge, it can accept up to 2 hydrogens and remain an ion. So you can have PO4 with a hydrogen, so just HPO4. So that would be 2 negative, and that's called hydrogen phosphate. Again, given to you in your complex ion chart. So hydrogen phosphate. Or you can add yet another hydrogen to that, so H2PO4, and then the charge would go up to negative, and this would be called dihydrogen phosphate. So looking at the next section here, it says, what name would we give to the HSO4 minus ion? Well, it's sulfate plus a hydrogen, so we would say hydrogen sulfate. And we could call that one also bisulfate, so either of those two. And HPO3, 2 negative, well, PO3 is phosphite. So with a hydrogen, we would say hydrogen phosphite, and that would be the name of that ion. Note that we can't say biphosphite because we use bi when we cut the charge in half, right? So for example, HCO3 has the charge is divided in 2 from the 2 minus, so we say bisulfate, or sorry, bicarbonate, but you can't use the bi prefix for the phosphate because you can't cut a 3 negative charge in half. Okay, and that's it for this section.